In this video, we will answer the following question. So it says, take f of x to be equal to x squared. Using the definition of a limit, prove that the limit of f of x as x approaches 2 is equal to 4. Okay, so how do we use the definition of a limit to find that? So the definition of a limit states that for every epsilon greater than 0, there exists a delta greater than 0 such that such that such that 0 such that if 0 is less than modulus of x minus a modulus there is less than delta, then modulus of f of x minus the limit is less than epsilon. So this is the definition of a limit. So we must use this definition in order to prove that this limit exists. So one can say that is obvious. When you put 2 and square it, you will get 4. But we must use this definition to prove that that is true. Okay, so I will erase this part and then we will write in terms of the question and what we've been given in that question. So how do we work that out? So for all epsilon greater than 0, there exists a delta greater than 0 such that 0 is less than modulus of x minus, in this case our a is 2, and less than delta. So such that if this is there, then we have that f of x, modulus of f of x. So what is our f of x in this case? Or f of x is defined by x squared. Okay, minus the limit. Our limit is 4 is less than epsilon. So we must use this here in order to prove that that is true. So our end goal is just to get an epsilon. Then we would have proven that this is true. That's if for every epsilon, no matter how small it is, there must exist a what? A delta. So we must start with the point where we have an epsilon. Then we build up into getting a delta. Then we use that in order to remain with epsilon only. So for every epsilon, there is a delta, as we have what we have said. So meaning we must start with this same part, x minus 4 less than epsilon, since this is the part that's having the what? The epsilon. So for every epsilon, there must be a delta. So now let's work this out in order to get a delta. So we must work out such that we see something similar to this here. See something similar to this. So from the looks, I can factorize that. So modulus of x minus 2, then that's x plus 2 modulus less than epsilon. So I have factorized. So from here, since this is multiplication here, it's a product inside, I can write this as a product of the modulus. So I would write x minus 2 modulus x plus 2, like that, less than epsilon. From here, I cannot divide to remain with what, with x minus epsilon here, because I will have to limit the values of what, of x here. So I must get a definite point of what, of x. So what I'm trying to avoid is making this here, this part, to be what, to be 0. So that's why I need to choose and get a definite point there. So my aim here, when where we've reached, is to remain with what, with this here, x minus 2 to be less than what, epsilon. I don't know, it can be over something or just like that. So that is my aim. So how do I do that? So I say let epsilon, let modulus, I mean, x minus 2 to be less than, so I choose it to be less than. So I have to choose a very small value of epsilon. So what small value of epsilon can I choose here? I choose my epsilon to be 1. So I choose it to be what, to be 1, to be less than 1. So if it's less than 1 here, so you can choose any value very small, so, or any value small, but I am avoiding to work with fractions, so I use 1. So if I use 1, then I can redefine this as how as how a modulus is defined. Then it will be minus 1 less than x minus 2 less than 1. So then adding 2 on both ends, I will have 1 to be less than x less than 3. So I will choose the what, the bigger one on any of what, over 2. You always get the larger value. In this case, the larger value is what, is 3 there. So when you get your 3 there, so you say your x, let my x be equal to what, to 3. So when you have your x there equal to 3, what you will do is, from where we ended here, there, you will replace this part here where there's x plus 2. Where there's x, you replace the 3. So when you replace that there, you will have the following. So you have x minus 2, then there you will have 3 plus 2 modulus less than epsilon. So you have this. So this is going to be modulus minus 2, then that will be what, 5 less than what, epsilon. So here I have a definite what's this value, which is 5. I have a number here, so I can divide this 5. Since from here on top I have this x minus 2 to be less than what, than delta. So I know this side here can be related to what, to delta. So I just divide this there. So I divide my what, my 5 on both sides. So I will get x minus 2 to be less than epsilon over 5, like that. So from here you will say I choose, or you may, yeah, you choose. So here you choose your delta. So choose your delta, since here we have this and this here is less than what, than delta. So meaning this can be this here also be what, will be in the same range, less than what, delta. So I can choose my delta to be what, to be this, to be epsilon over 5. That is my what, my delta. So after choosing that, then I must show that what I have chosen works. So how do I show that that works? So I will start from the modulus again, modulus of x squared minus 4. Then I know when I factorize this, or what we just did on top there, I will get this here. I will get x minus 2, then x plus 2, like that, modulus. Then this is equal to modulus of x minus 2 modulus of x plus 2, like that. Okay, so now I know from what I had written to say this will be equal to this part here is what is 5, from what we chose to say our x should be what should be 3. So I will have x minus 2 modulus like that 5 there. So after having this, what do I do next? So this here, we said from the top here that it is less than what? Delta. So meaning there, this will also be what? Less than here, delta. So delta, I can replace there delta less than what? So this is less than delta 5. Okay, 5 there. So I will get that. Now I know that this will be equal to, okay, what will that be equal to? I know my delta because I chose my delta to be epsilon over 5. So that will be epsilon over 5, like that. Then I have my 5 there. So the 5 and the 5 divide, then I will have epsilon remaining only. So I have used the definition of the limit in order to prove that the limit of that function is equal to 4. Thank you for watching. Remember to hit the subscribe button.